Okay, quick lesson on components of vectors. When we take a single vector that's given, every vector that does not lie directly on the x or y axis has two components. So for example, I have listed here a given vector A, velocity vector, since this is meters per second, is it going 15 meters per second at 50 degrees. If you may have watched the other video about direction, if it just says 50 degrees and 50 degrees only, that means it's terminal in quadrant 1 from the positive x-axis. So right here is our 50 degrees. Okay, and once we draw it on an XY coordinate grid, it's pretty simple getting the components. We'll just complete a right triangle head to toe with what we'll refer to as the components here and here, and we'll give this one simply the name A sub x for the magnitude of the x component and A sub y for the magnitude of the y component. At this point, it'll just be using SOHCAHTOA, since we know that the magnitude of vector A is 15, given up here in the original vector, and it'll just be putting together the simple pieces of SOHCAHTOA. So let's start with finding AX first. AX, compared to the reference angle of 50 degrees, is the adjacent side, and the side we already drew originally that was known was 15, the hypotenuse. So thinking about what trig function represents or uses adjacent and hypotenuse, that would be cosine. So we could say the cosine of the angle, in this case 50 degrees, is equal to adjacent, or in other words, more specifically, my x component side over the hypotenuse, which specifically we know is 15, or generally just the magnitude of A, the vector we were given originally. At that point, solving this is simple. It'll be AX equals 15 cosine 50. And you could run that in your calculator yourself. You get the point of how to find that. There's no need to find the direction of components, because other than noticing that they're either on the positive x, or possibly, if the original vector was in another quadrant, the negative x side. That'll be more important when we do component method, and I'll talk about that more in the next video. Okay, very similar to that. Let me get this out of the way here. If we want to find and calculate the y component of my vector, well, same idea, SOHCAHTOA. The y component is the opposite side, and we're still going to use this as my hypotenuse. Opposite over hypotenuse is the sine function, so we could say sine of 50 degrees is equal to the opposite, or A sub y, over A, which is 15. So for this specific example, it looks like this, and we could say A sub y is then equal to 15 times the sine of 50. And make sure your calculator is in degree mode when calculating that. And that's pretty much it with individual components of vectors.